Many times we realize that we have been over applying a good thing and actually going backwards in the process. If we can give the nutrients to the tree when the tree needs them at the right amount that the tree is calling for and what that crop needs, then we will see at the end of the year when the crop comes off a much better return to the grower for that initial investment in fertilizer. In the future, nutrient management will play into the sustainability of our industry. We have to be able to show that we are accounting for our inputs. If an input is needed, we're using it, and we're using it at the right time and the right amount. That will allow us to show to our community that we're being responsible with the resources that we're taking in order to provide almonds and ultimately a food source to the community.
One of the real issues that we've not perhaps dealt with adequately in almond nutrition is to think about how all the pieces fit together. We constantly think about nitrogen, but indeed you've got to think about potassium, you've got to think about any of the other nutrients that might be limiting the efficiency with which you are using nitrogen in your field. That's going to be important. We're under a lot of pressure in this industry to clean up the nitrogen that's in the environment. You can do that by becoming more efficient, but you can only become more efficient if you cross off all the missing air elements in the field and address the integrated crop nutrition and also, of course, irrigation as well. I think this is going to become a much more prevalent theme in the industry itself, that we start to think about optimizing each individual field. To a certain extent, we may ultimately have to think about optimizing within the field, making sure that every part of the field is producing at its optimal potential. And that's the surest way to improve the use of nitrogen in California agriculture.
As we get into some of our second and third generation orchards, now we're starting to mine a lot of the nutrients out of the soils that we didn't necessarily see in first generation orchards. So it's important to replace a lot of these things, as well as maintain them at a level that we don't get deficient going into a next season's crop. Over the years, we're constantly pushing for higher and higher yields. Nowadays, we're striving for 4,000 plus pounds. And as you do that, it definitely uses a greater amount of nutrients, and not just NPK, but micros as well. So it's critical to keep all these levels adequate, because we don't want to get a deficiency and then address it. By the time you do that, it's already affected your production. Definitely our newer technologies, especially in the delivery systems like the micro irrigation systems, drip and micros, has definitely enhanced our ability to micro feed or constantly feed during the entire season, both allowing us to address critical levels at critical timings, as well as applying it at the most efficient times for uptake. So that's been really important for the growers. Challenge-wise, one of the things obviously is knowing something that's a legitimate product versus something that's of dubious nature, and that's always something a grower has to deal with. I always stress, look into the research side of it. I always like companies that have, whether it's UC research, in-house research, or third-party research, it reinforces to the grower the legitimacy of the products. And, you can't ignore cost. There's obviously costs involved in innovation and patents and things of that sort. So most of these things are going to be fairly pricey, but as a general rule, there's a good ROI to the grower by having a comprehensive nutrition program.
So it's evident today that we need to be more conscious of the impact that our production practices have on the environment and on consumer choices, and we really need to commit ourselves to continuous improvement. So the question is, where do we start? And we need to start with really understanding the tools and resources available to us in the industry, and we need to start with a comprehensive crop nutrition approach. By taking a holistic view of how we manage crop nutrition, it's going to allow us not only to increase our productivity overall, but also our profitability and increase the efficiency of our nutrition inputs on our cropping systems. And at the end of the day, we need to not think about these sustainability and regulatory challenges as an additional cost of doing business, but really as an opportunity to progress in our practices. So this is where Yara's My Almond program originated. It's a commitment that we made to the almond industry to improve upon our fertility management practices. And it really starts with, again, understanding what resources are available in the industry to help us understand how we can feed the tree basically exactly to that tree's needs and turn more fertilizer inputs into yield as opposed to waste. The problem is that these initiatives really only exist as a marketing ploy unless we have the ability to ground truth them. And so that's where the My Almonds Incubator Farm really comes into play, because it gives us that ability to really truly vet the impacts at the local level of our crop nutrition practices and our recommendations, and be able to see how we can improve upon those over time with this 10-year-long commitment that we've made here.
Underway at the farm are multiple trials to unearth the crop response to static, reactive, and proactive fertility management programs in a commercial orchard setting. Re-engineering the irrigation infrastructure to accommodate a randomized block design allows us to accurately detect variability between treatments with the utmost precision. The baseline program is a static, fixed input program that incorporates SOP and UAN 32 in addition to basic foliar nutrition. The modified program is built the same as the baseline program, though Yara Leva Can 17 is used to supplement the UAN 32 for nitrogen demand. The improved program relies on Can 17 and CN9 for nitrogen demand, and this program is really designed to be reactive to emerging nutritional deficiencies. While the My Almonds program takes a comprehensive and proactive approach to crop nutrition, the fertilization schedule incorporates a high-frequency, low-volume approach, and the nutritional plan is amended throughout the season based on insights from digital tools, visual observations, and analytical data. In this presentation, we will primarily focus on the treatment level effects between the baseline and the My Almonds program to highlight the polarization of management styles that currently exist in the industry and to show the value of a comprehensive crop nutrition approach. There is no one-size-fits-all program that exists, but really, if we're better to able to understand the process and framework to make more site-specific and crop-specific recommendations within the bounds of our local infrastructure, we can enhance the efficiency of all our nutritional inputs while simultaneously returning a better profit margin and ensuring our right to farm in the future.
So as with any commercial orchard, there are challenges to developing and implementing a comprehensive crop nutrition program. And our field this year was no different. We ran into challenges with sodium in the irrigation water that we had to adjust our potassium and our calcium cations when developing this full program. We had irrigation infrastructure challenges that required quick troubleshooting to make sure that we were keeping our programs on track. And additionally, we had logistical issues trying to manage a whole complex network of inputs that were required based on the design of this program.
On our soil samples, we start by assessing the base saturation elements in our samples that can act as a guide to our overall chemical balance or imbalance. These primary base saturation elements represent a relative abundance of exchangeable calcium, magnesium, potassium, sodium, and hydrogen, and that are attached to our soil complex. We must understand where this balance needs to be based on our soil's cation exchange capacity, or CEC. This can generically be thought of as a relative measure of soil texture. Next, we convert all of our individual nutrient values into a pounds per acre basis to support our recommendations that require a pounds per acre value for our nutritional inputs. Computing these elements will help us understand the impact that specific imbalances have on our pH. And lastly, we need to assess the levels of organic matter and soluble salts, as they will have direct impacts on nutrient and water availability to the plant. Once we have an understanding of the condition of our soil, we'll look to our irrigation samples to understand the balance of chemical inputs relative to our irrigation and how that can impact the balance of our nutrients in the root zone. Now that we have an understanding of our site-specific potential and limitations, we're layering in our crop-specific needs and building out our inputs by demand and a prioritization of our crop goals. Crop-specific needs start with crop demand and uptake curves. We're fortunate enough in the almond industry to have access to more detailed uptake and demand curves compared to many other permanent crops. These curves tell us what the trees need in total nutrition for the season, as well as relative amounts of each individual nutrient that is required through the various phenological stages. These uptake and demand curves help us guide our comprehensive crop nutrition management approach by allowing us to balance the needs of what our soil and water contributions might be, and finally driving our supplemental inputs. This next to last step is essentially a plug-and-play strategy. With an understanding of the crop nutrition tools that we have access to, we start layering in applications of specific nutritional inputs to meet our supplementation needs by crop stage. We need to be cognizant of the relative nutritional value of our inputs, as well as the synergistic or antagonistic properties of the specific nutrient form of all of our crop nutrition products. We must also be aware of our desired application method for each nutrient to achieve maximum efficiency by making sure those nutrients are delivered in a way that promotes maximum uptake. This process described is essentially the 4R approach in a practical application. Lastly, by following these steps in building a comprehensive crop nutrition program, we have also built out the 5th R, which is return on investment. The 2020 crop year was very successful at Yara's Incubator Farm. We observed double-digit improvements with the My Almonds program on nearly every metric that we looked at. We attributed the success of this program to the comprehensive crop nutrition approach, coupled with a practical application of the 4 R's of nutrient stewardship. The improvements seen this year not only produced higher profits in the current season, but also greater crop potential leading into the 2021 season. It's also important to recognize that these results were able to be attained within basically one full cropping season, as our applications for the 2019 year were quite limited due to the redesign of the infrastructure. This really highlights the potential to improve your yields and return with relatively easy adaptations in your own fields. So let's dive into the results and we'll work our way through the season. Starting with nut set, we selected 30 trees per treatment, broken up by 5 trees per replication. During the delayed dormant phase, these trees had a single branch flagged at a point where there were approximately 100 flower buds positioned. We documented the total flower buds at that time and returned after June drop to identify the percentage of nuts remaining. Though nut set is not a proxy for final yield, it can be seen as a relative measure of crop potential maintenance. The My Almonds program, in this case, showed a 16% improvement compared to the baseline treatment. Next, using the same trees from the nut set analysis, we measured trunk growth throughout the season with an initial spring measurement followed by a fall measurement. Though the improved program produced the greatest growth at over 27% over the baseline program, the My Almonds program also produced a substantial 14% improvement. This increased trunk growth can improve total nutrient and water movement through the tree. In an attempt to better understand nutritional impacts on whole rot, we again used the remaining nuts on the branches from our nut set analysis to quantify whole rot incidence. Now this is basically identifying holes that visibly had whole rot versus those that did not. Now whole rot is like the worst gift that keeps on giving. It creates more stick tights, resulting in less yield in the current year. It leads to fruiting spur and shoot death. And lastly, the mummies that are retained from the current year can end up at the processor the following year, resulting in quality reductions due to discolored nuts. This year, we observed a staggering 28% reduction in whole rot incidence between the My Almonds program and the baseline program. The reduction in whole rot is likely due in part to our overall nitrogen use efficiency. The high frequency, low volume, quote unquote spoon fed approach again proved superior in the field. We calculated a combined efficiency of 90% in the My Almonds program compared to 73% in that baseline program. In line with the Almond Board 2025 orchard goals, we also looked at our water use efficiency. All treatments received the same 34 inches of water this year, though the yield differences supported greater water use efficiency by over 19% in the My Almonds program. Our calculated efficiency was only 13 1/1000ths of an inch of water per kernel pound of yield. While all of these results point to greater input efficiencies and increased crop potential for next season, the improvement in the current season's yield was equally as impressive. We saw a 24% combined improvement between the My Almonds program and this baseline program. The difference equates to over 500 pounds per acre in the first full crop year. This is a testament to the ability of a well-crafted program to thoroughly set, maintain, and really grow a better crop. And now for the moment of truth, profitability. Now there are challenges before us that are pushing us to be more environmentally friendly or quote-unquote sustainable. It is important to recognize the pillars of sustainability in this argument though. In no particular order, those pillars are social equity, environmental stewardship, and economic viability. Now, this last one is key because we can adopt many practices that are viewed as socially equitable or environmentally friendly, but at the end of the day, if we are not simultaneously improving your profitability, then the structure is broken. There's no question that the My Almonds program came in at a much higher price point than the other treatments, but what matters most is whether or not this My Almonds program was sufficiently suited for our site to improve the bottom line. In the end, we saw a 19% improvement in net return from the My Almonds program after factoring in the cost of the inputs. The My Almonds program paid for itself and then contributed an extra $750 an acre back to the grower.
So in the end, this was a really productive year for the Incubator farm here in Modesto, California, and the results that we were able to obtain here have real implications for growers and the industry. You know, we kept our foot on the gas throughout the course of the season, not just because the design of the trials themselves, but also because we truly felt that we had built a very strong agronomically sound program. Now, even though the prices dropped almost 30% in some cases through the course of the season, again, we still kept our foot on the gas, and that approach of looking at nutrition from a comprehensive, through a comprehensive lens really, allowed us to not only pay for the program, but we still, at the end of the day, produced a net ROI increase of over $750 an acre back to the grower. So additionally, these double-digit increases that we were able to show on nearly every metric just really highlight the fact that with careful planning and execution, that a comprehensive crop nutrition program can not only increase our productivity, it can also help us translate more nutrition inputs into yield and less waste, but additionally, it helps us improve the value or the relative value of our fixed costs for things like bees that we have to put out every year, irrigation water, equipment costs, and costs associated with the land. So with all this being said, you know, here's the real call to action. We need to push the boundaries of what is possible and really not be bound by what is conventional. We know that change is not easy, but it is inevitable. And if we are able to look at, you know, these growing regulatory and sustainability challenges as less of a burden and a cost of doing business, but more as an opportunity, it helps shift our way of thinking, right? And one way of doing this and shifting this way of thinking is starting with the question, you know, am I in the business of saving money or am I in the business of making money? And this can help you fundamentally change the way you approach your crop nutrition management for the better, for, you know, improved practices and improved production and return on investment.